Here in this video, we're going to look at identifying the intervals for where our functions are increasing and decreasing. Though before we look at that, I want to look at another problem first here. We're given the function f of x equals a negative 3x plus 5, which is simply a straight line over here. And here's the graph, and it's going from negative 10 to 10 on the x, and this is negative 10 to 10 on the y-axis. And it says we want to determine the intervals for which f of x is greater than or equal to 0. Well, when we say here f of x is greater than or equal to 0, this is the same thing as saying that our y is greater than or equal to 0. So if we look at our graph, where is our graph greater than or equal to 0? In other words, where's the graph either on or above the x-axis? Well, if we look, right here is where the graph touches the x-axis, and this top part of the graph is above the x-axis. So if we want to identify the intervals for where it is above the x-axis, so the intervals that we're talking about here, keep in mind these are going to be x values. Okay? So if we look, as we think about reading a book, the same thing we want to look at this graph. If we start over here at the left, as we go from left to right, starting here at negative infinity, the graph is above the x-axis. Now, right at this point here, the graph goes below the x-axis. So all the way up to this point. Now we need to figure out where's this point right here that it starts to go below. Well, this happens to be our 0. So if we find the 0, we'll know what this point right here is. So where's this point? Well, we can take our function, negative 3x plus 5, set that equal to 0. So we have a negative 3x equals a negative 5. So x equals negative 5 divided by negative 3. So we have x is a positive 5/3. So we know that this point right here is 5/3. So all the way up to that point, now again, these are x values. So if we start here from negative infinity, all the way up to this point here at 5/3, over this interval, the graph is above the x-axis. So if you look from this red line here at 5/3, over here from negative infinity to that point, notice that our graph here is always above the x-axis. Now, one mistake I did make here, this goes to 5/3, and really here I should have used what? Because 5/3 is actually on the x-axis, so it says it could be equal to 0, I would use a bracket. Okay, and that's because it says it's greater than or equal to. If I looked at the problem a little bit differently, if they would have said we're looking for where the function f of x is strictly greater than 0, notice then the interval would have been negative infinity up to 5/3, but we would not include 5/3, so instead of a bracket we would use parentheses. So therefore we're going to use parentheses because it is strictly greater. The graph is going to be greater than 0. But for this problem it says greater than or equal to, so therefore we would use a bracket on the 5/3 because at 5/3 the equation is equal to 0. So really we're looking at the interval where this function is greater than or equal to 0. And if I looked at another example here, same problem, if I would have said we want to find where is the function f of x less than or equal to 0, well, then that's looking below, so then that would start at 5/3, and again, because it's equal, we would put a bracket on 5/3, and then all the way over here to infinity would represent the graph being below the x-axis. So that's where the function is less than or equal to 0. All right, now, the rest of this video, we're going to look at finding increasing and decreasing functions. So here we have our first example, f of x equals x squared minus 4. And here's the graph of our function. We have a nice parabola, and this is, once again, negative 10 to 10 on the x and y axis. Now, we want to identify where is the graph decreasing and increasing. Well, if we look, again, we want to think of going from left to right. our graph here is going down. So here it is decreasing all the way until we get to this point here. So that means we're starting over here from the left at negative infinity until we get to this point, which happens to be here at the origin. So that would be negative infinity all the way to 0. So here our graph is going to be decreasing from negative infinity to 0. Now keep in mind, these are x values that we're using. We're only looking at values on the x-axis. So that's the interval. From negative infinity to 0, our graph is going to be decreasing. And then our graph is going to increase. From this point on, it's going to start increasing. Well, that's starting here at 0, and then it's going to always increase to positive infinity. So the interval that it's increasing then would be 0 to infinity. And if we look closely, the other possibility is it could be constant. Well, if we look here, there's no place where the graph is constant. If your graph was constant, then that means you would end up with a horizontal line where there is no increasing or decreasing. It remains constant. So in this case, there are none. There's no intervals there. Okay, so again, we're decreasing and then we're increasing. Now keep in mind when we're labeling these intervals of decrease and increase, these are not points, these are your x values here. So basically we're saying we're starting all the way over here from negative infinity and we're going all the way to 0 within this interval from here to here. It's decreasing and then it's increasing from this interval all the way over here to infinity. All right, here we have another example. F of x equals the square root of x squared minus 1. Again, we want to look at where is the graph decreasing, increasing, or constant. Well, clearly if you look at the graph here, we start all the way to the far left at negative infinity. Our graph is certainly decreasing, and it's going to decrease all the way to this point right here. And based on this graph here, again, this is going to be at negative 1. Okay, and if we can't identify that clearly from the graph, then we could always take the equation, the square root of x squared minus 1. We could always set that equal to 0, and if we square both sides, we would have x squared minus 1 equals 0, x squared equals 1. So then we would take the square root and we would get x equals plus or minus 1. So we know that's a negative 1 right here where it's 0. So the graph is going to be decreasing from negative infinity all the way to a negative 1. And then our graph starts to increase, and again this point here would be at the positive 1. So it's going to increase from 1 all the way over to the right. It's going to keep going up to infinity. So it would be 1 to infinity. And then of course, is there anywhere on the graph that it is constant? And we do not have any intervals that it's constant because it's either decreasing from negative infinity to negative 1, and then there's a break in the graph from negative 1 to 1, but then the graph continues from 1 to infinity, it is increasing. All right, here we have our last example, and here we just have the graph. So if we look at this, our graph is increasing. Okay, if we look here, our graph is increasing here, and we could say that it starts over here at negative infinity. So we're increasing from negative infinity all the way to this point here. Well, where's this point? Well, this point is located at 0. Okay, so negative infinity to 0. And then what happens at 0? Well, then we have a horizontal line. It's not increasing or decreasing. So starting here at 0, our graph remains constant. So that's starting at 0. And then it stops here at 2. So from 0 to 2, our graph is constant. And then what happens? At 2, then it starts to decrease. So we're going from 2 to infinity. So as we go from left to right, just like you're reading a textbook, you start at negative infinity. Our graph is increasing, 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 and then we get to this point where, where's this at? Now be careful, we're looking at the x value. We're not saying it's increasing up here to 3, that's the y value. The x value is 0. So from negative infinity to 0, this graph is increasing. And then from 0 to 2, down here on the x-axis, from 0 to 2, the graph is constant. And then from 2 to infinity down here, the graph is decreasing. So the biggest thing you need to be aware of with identifying the intervals for increasing, decreasing, and constant is that you need to make sure that these values that you're listing are the x values down here, because these are labeling the intervals on which you're increasing, decreasing, or remaining constant.